Hello, everybody. I received a call from a friend of mine this morning. Well, actually, it was last night because it is kind of late right now. Um, the call was in regards to not understanding the concept of summarization and where to use it, how to use it, and how to figure it out. Well, the concept of summarization is taking multiple routes with in the same range, in the same hierarchical model, and reducing them down and finding the most bits in common and breaking it down so that the final summary is one IP address route that that encompasses all the routes you need to cover. So what does that mean? Well, that could mean several things. That's kind of cool. What it mostly for the most part means is when you have um, when you have typically in any situation where you have multiple routes within the same range, meaning this right here would be considered within the same range because of the fact that they are all 192.168 routes. They all fall into the same hierarchical model. Hierarchical model means does it fall under the 10 network, the 172.16 through 31, or 192.168? And because those are your private address ranges, slash 8, this one is a slash, what is this one? I think a slash 10, 172.16. Yeah, I think this is a slash 10. This one's a slash 12. Um, that's the range that they give you. So well, technically this would be a 16 because it only goes 192.168. This is the only one that changes. But the point of that is you have to have something with a hierarchical model, which means you can't have a 10 network slipped in here or a 172 network slipped. This couldn't be a 10 network. This guy couldn't be the 172 network and be able to summarize. It has to be all in the same range for you to work. So, like if you're driving down the street, this is your block. So this will say this is 10th Street, USA. If you have a house here, a house here, a house here, and a house here, you might have house 2, 4, 8, and say 12. Okay? What you can say is houses or addresses 2 through 12 on 10th Street, you need to go to them and deliver these packages because you're able to summarize it into one range. So that where in this case you would say you would have to give a beginning and then an end, where in summarization you encompass it based on the bit value and then you go from there. So the way it actually works, I need to, it's gonna, darn, it's not gonna work. I encompass too much. Hmm. Oopsie. Hmm. Anyway, um, the purpose, like I said, behind the summarization is to find out how many bits in common there are. So the idea of it is once you've found how many bits are in common, you find out what the range is, and that becomes the summary address. Fairly straightforward. Now, why would you use summarization? Okay, what's the purpose behind it? Do you just sound cool in the network room when you say, "Oh, I summarized the 10 network on router 7 at branch 3 down to one address and encompasses 64 addresses. Good job. It's really not going to be something you're going to get high fives and you save the world. Nothing like that. But where you can summarize and where you should be summarizing is at the OSPF area border routers, because that's going to be where area 0 and area 1 meet, and you're going to have a router right here, and this router is going to have routes coming in here and routes coming in here. So what you would do at this point is you would say, okay, area 0 and area 1, you're going to go in there and you're going to say, this guy's like, the 10 network, and he's got seven networks. So you'll find out what the most bits in common are, and once you know how many bits are in common, then you can go in and select by the range. What do I mean by the range? Well, it goes back to subnetting. So by default you have 128, 64, 32, 16, 8, 4, 2, and 1, which is your you've got your 8-bit placements, okay? So what you would do is you would find out how many IP address ranges you have. So in this case, I'm using 24, but I wanted to encompass the ones where you're going to see that I tried to keep it in bit order, move it one bit placement to the left for each design, so that you would at least be able to see what you would do. So at this point, you would go and you would say, you've got the 1 network, the 2 network, 3, 6, and 24. Now assuming I'm leaving out 4, 5, and then 7 through 23. The purpose for that is I didn't have room. But the concept remains the same. So what you would do is, let's say for instance you didn't have the 24, it was just the 6. So what you would do is you would find out how many bits in common there are. Well, in this case, let's see if I can copy this and move it. So in this case right here, you have a situation like this, where you have, well, these are just a hair off, but the concept remains the same. You have 1, 2, 3, 4, 5 bits that are all the same, okay? And then you have 1, 2, 3. So you would look at this one. This would be the first one that's different, but it's still good. Like I said, you're still looking for bits that are the same. So that would be the beginning of your range when it comes to summarizing. So what you would do in this case, I'm going to move this out of the way so that I can deal with that. And what I'll do is I'll draw a skinny line. And I'll try to draw a very straight line. Hold on one second. Okay, so the beauty of power of recording, I drew a line right here. And what that does is it cuts a line where you see the ranges pop up. So I'm going to make my line a little bit bigger. So what you're going to do is you're going to count the bits. 1, 2, 3, 4, 5. That's how many bits are in common. So you come over here and you go 1, 2, 3, 4, 5. That's going to be your summary. Well, theoretically speaking. That's the well, I'm trying to figure out the best way to put it. Sorry, I was looking at it and I'm like, well, they're not going to get that. But what I wanted to reiterate was this. This is how many bits are in common. You got 1, 2, 3, 4, 5 bits in common. So you would come over to your subnetting area and you would put bits and placements right here. So we're in the 3rd octet. Okay, these are the octets. So this is class C, class B, and this is class A. Okay, so you're in your class B octet, so you're in your 3rd octet right here. So in this range, this is the range you're going to be working inside of. in order to grab all of these routes to be encompassed, the 1 through the 6, you're going to grab, this is the last one, this would be technically your range, so then this would be your summary address, your /21. So what you would do is you'd write at 192.168.0.0/21. That would tell the router. It would be in the routing table. You would see it show up as a /21. I had to think of what it was going to be because it's been a minute since I've actually implemented it. But that's the concept. So let's assume for just a second that this guy we were encompassing the entire range for the /24. Okay, so the /24 and 1 second. The green line is the bits in common. So what you would do is you would count 1, 2, 3 bits in common, and then you would come over here and go 1, oopsie. You come over and go 1, 2, 3 bits in common. This would be your new summary slash notation. So this would become a 19. Okay. Actually, probably would be easier if I just erase this. This would be a 19. The reason it would be a 19 is because you've got the first 3 bits in common. This would be the slash notation for the 32. What does that mean? Well, you would have you go based on your range. So 32 would be your range if you were subnetting it. So you'd be through dot 32. Okay, would be your next range. So that means this summary address right here takes care of 0 through 31.255. Okay, so then when you're dealing with a bit placement, okay, if there's no bits in this location right here, if this was a 0, it'd be a /24 as your connection. Now, if you had bit is turned on, one automatically becomes a 23 /23 out of the gate. So that's the way you remember that. Okay, because you're turning a bit on, even though it says 1 bit here turned on, would technically you could still use it as /24, but as a summary route you could be more specific and say, well, it's a /23 subnet. So you theoretically, if you had all the bits turned on, it'd be a 255 mask, which would be a /24. So even though this one right here says it's with the 1 is turned on, in summary terms, this would be a /23. Okay. Now, with that being said, because you're having at least 1 bit turned on, it's the way it would go. I don't really have a really good explanation, but there are some things that you don't have to go in depth on your explanation to explain why. Now there are, like I said, there are some caveats to summarization, and that would be one of them. Do you really need to summarize for one route? No, you don't, because you wouldn't. You'd put in there 192.168.1.0/24. You wouldn't summarize that down. Now, if you had the 2, you could definitely summarize. Because you could be like the 1.0 and 192.168.1.0 or 192.168.0.0/22. Or sorry, /23. So you could do that. Typically, you're not going to summarize for just 2 routes. You can, and you should, but you don't have to. So if you're in an exam and they make you tell them what the summary address is, they're typically going to throw at least through a 3 or a 4, maybe even an 8 or a 10. and just to make you have to add a few extra bits in there so that it actually makes it worth your while to go in there and actually try to figure it out. Now, if you see a range right here, this guy, /24. This guy right here, because it's in the second placement, this right here is still technically considered a /24, even though typically you would put in there as 1.2 or 1.0, 2.0/24s. That's what you would put it in. But you could summarize this down to a /23. Now, the 3, it's a little different because you're encompassing a little bit more because both bit placements are on. Still considered a /23. Now, when you come down here, you're in the third placement. You're in the bit 4 /22. This right here would be a /22. Okay. Why? Well, because you're using 1, 2, 3. Because you have 1, 2. Oh, you guys probably can't see that. Yeah. 1, 2, 3, 4, 5 bits in common. That's what you're looking for. It doesn't really matter what you have here. It's where do the bits stop. So if you have a 24, the bits would stop here. Okay. That's where your bits would stop. So you would come in here and go 1, 2, 3 bits in common. So you put them, you'd figure out what the bits in common are. What I would do if I was going to go into an exam, and so every time I go into exam, I always write this out. I write this little section in here. Class B through, God, that was horrible, 2 in a row. B through C. So you're going to go 16, or well, I do 17 because I know 16 is going to be considered, well, you could do a 16, but I do 16 through 24. I just write them out real quick. And then what I do at the very bottom is I go, because it goes, actually I have a, give me 1 second. I have a chart written out that encompasses the bit placement. I have the subnet mask for it, and then the slash notation for it. So I know this is going to be a /25, two subnets, so on and so forth. The base network and the broadcast, base network and the broadcast. So anything that falls in between there. So when I'm studying, I can just quickly put this in. Now what I would do in the exam is I would write this out right here. That entire section right in here, I'd write that out all the way to the class B. I'd write out to the class B, so then when I'm done with it, or when I'm going through and it says, it'll give you an indication like, say, it'll say, what's a range that you could do? 172.16.3.61/22. Is that a valid IP address? Or actually, let's do a /2028. To be like, is this a valid host IP? You might see that. You just see it all the time when you're taking practice tests that I see online. So you take a practice test and you see, is that a valid IP address? Or it'll say, going based on, and it'll give you a bunch of IP ranges, and it'll say, out of the ranges posted with it, and what you're actually looking for is a slash notation, because then that'll tell you what your range is. A /27 is 32 hosts. /26 is 64 hosts. Once you know your slash notation to your bit placement, which comes back to this. So as long as you know what your bit placement is, how many bits are turned on. So if you know a /27 is the same as a 32, because this is class B right here that I'm working with. As long as you know that, then everything else should pan out. If you don't understand subnetting, you're going to have a hard time with summarization. That is the idea. So, for those of you that struggle with summarization, I recommend you get stronger with your subnetting. And once you get stronger with your subnetting, you need to learn what your slash notations are, what your subnet mask slash notations are going to be referred to as, so on and so forth. So when you get done with it, you should be able to write out slash 16 through slash 32. So it'll be, let me slide this over to the right just a bit and bring this down. Oh, that doesn't give me a lot of room to work with, does it? Actually, let me clear some of this area out here. So you're going to want to write out slash 16 through 32. And what that's going to do is it's going to give you an entire range. The bit placements aren't going to change. You're going to go 128, 64, 32, on down. And then when you get down to 1, the next one's going to be 128. So this will be 1, 4, 8, 16. And you're going to write this all out. What I would do is I would put a slash right here, so you know that this is B to C, and then 64, 32, 16, 8, 4, 2, 1, and then the slash 17, slash 18, slash 19, so on and so forth until you get to slash 32. So then you know this is a host IP. This right here is a slash 24. Okay. If you can write all that out and then put the subnet mask on it, so like 128 is going to be obvious, but 192, 224, 240, so on and so forth, all the way down, then you're going to be able to quickly identify based on the octet. So if it's giving you your range like this, or it might even say 172.22.31.16 slash 17, is that a valid IP address? So then you got to come down here, figure out, well, 17's right here, or I'm sorry, 17's right here, by looking at it, yes it is. Then you got to figure out what your range is, 128, so you have to go 128, and then you have to understand your subnetting. So for every two 128s, that's an entire 256, which is an entire range in Class C. So you have to know how to break down your subnets. So that's why I say subnetting is such a crucial part of going into an exam. If you understand it, understand subnetting, you'll understand summarization. Because all you're doing is you're looking at how many bits are in common here. So if you have multiple bits in common, now I'm in the Class B range. Let's say, for instance, you have this bit here is turned on, this bit are turned on, and then this bit is turned on, and this bit is turned on. Well, obviously, right here is going to be the most bits in common. So you're going to have 1, 2, 3, 4 bits in common. So it's going to be a 16, a slash, and in this case it would be a slash 28. Because you're in the Class C range. So 24, 25, 26, 27, 28. So it's going to encompass an entire class, slash 28. So your IP address would then be 10.1.1.0 slash 28. So you know at that point that your range is going to be 16. So the next one would be 16, then 32. So you know the first range right here will actually be 1 through 15. .255. Okay, so as long as you can understand how the ranges work, that's not gonna, it won't be an issue. Or I'm sorry, a slash 28, that's gonna be 16. So you're actually gonna have, I apologize, that's gonna be 0 through 15. I was thinking Class B, and then disregard the top one because that's not correct. I was like, why does that not make sense? So that'll be 0 through 15, 16 through 31, 32 through 63, and so on and so forth. If you can, or I'm sorry, through 47, 48 through 63. As long as you can understand subnetting, summarization, like I said, will come easy to you. There's no real secret to it. There's no tricks to it. It is very basic. If you can go break down your subnet down to binary, into the binary level, and be able to look at it and be able to figure out, you have to know what I lost my mouse, what this equals to in binary. So if you see a 64, you know in binary that is 1, 1, or I'm sorry, that is 0, 1, 0, 0, 0, 0, 0, 0, because there's only one bit turned on. 64 is going to be that. Now if it's, say 96, then obviously you have to figure out what 64 and 32 is. So if this bit was turned on and it was 96, you'd have one bit in common. It would be, and at that point you might as well just encompass the entire range. I mean, you don't have to. Let's say this guy is a slash, it's a slash 26. That's basically summarizing, because then you're summarizing the routes down to that. Now the benefit when it comes to the Class C ranges is if you have a slash 24, like a static route. Let me clean this up real quick. Let me grab all this. If you're in the Class C range and you're trying to summarize, you got a 10.1.1.1.0 slash 24 is going to be your base subnet, and you know that you're going to be working on the 64 bit placement, which means your ranges are going to be 64, 64.0, and then 64 is 128, and 192, and so on. You know that when you apply it to the interface, it's going to be a dot 192 or 64. So even though it's a dot 192 subnet mask, it's also a slash 26. When it comes to longest match, this will win over this for static route. Why? Because the router is going to look for the most bits in common, the most bits in common, the longest match. Because 26 is a more specific route than a slash 24, because there's more bits here than there are here. Because this is only 3 full octets. This is 3 full octets plus 2 bits in the 4th octet, which makes it 26. So that is how, and longest match kind of worked its way in there because it is what it is. So that is summarization. I know it's a little messy, it was maybe a little hard to follow, but it's one of those things where if you're and at the CCNA level, that's all you got to worry about. OSPF area borders or area border routers. EIGRP you can summarize on anyone. So like if you have several routes in EIGRP and you're seeing bulk, by default it auto summarizes. It's going to look at how many bits are in common. It'll auto summarize. Now for troubleshooting, it is good to turn no auto summary off, because then you can see all the routes. Because when it gives you a slash 22, where'd my thing go? A slash 22, that's a lot of ranges. Okay, but when you turn no auto summary, it tells you what's in there. So the 1, 2, and 3 networks, slash 24, slash 23, and say maybe the 4, because then this would be the slash 24 or slash 22. Maybe you have 4 networks, and maybe 3 is not working correctly. And you'd be able to figure that out at that point. But that's the basic concept to it. There's no, like I said, there's no magic to it. There's no secret. There's no fancy calculator that's going to figure it out for you. All you have to know is how many bits are if you were to take all your routes and lay them in one over the other, like I am right here. If you were to take all your routes, put them in together, and say, what's it routing for? Because if you do a show IP protocols, it's going to tell you what you're routing for. But EIGRP, OSPF, BGP, they auto summarize. So if you go in and find out that you're routing for 1 through 17, then you need to know what the bit placement is. So it's 16. That's the 4th bit in the placement. I'm sorry. Yeah. 4th bit, not the 5th. The 4th bit, and you got 1, 2, 3 bits in common. Then that's going to be your range, and then it'll end up turning out to be a slash 20 at that point. Or if it's a slash 17. If it's a 17, you can summarize to here, but it's going to, or I'm sorry, the 16. That's the one caveat that I forgot to mention. If it is a major number, like any of these, 4, 2, 1, and then you have a range that would fall in between, say, 4 and 8, it's like 5 and 6, you don't have a luxury of having that fall into this guy. So what you would do is you would summarize the most bits in common, which would be right here. So then what you would do is you would summarize for the 1 through 4 routes. So 1 through 4, giving you a slash 23. And then what you would do at that point, I'm sorry, slash 22. What you would do at that point is you would say, and then 5 and 6 would have their own. So you'd actually have 3 routes. And then you added 7, then you added 8, then you'd be able to resummarize and break that down to 1 through 8, which would also be, this is 16, that'd be 8 there, that'd be 5 bits in common. You'd put your slash in, and then you would go based on the slash notation. That is the easiest way to refer to it. So, if you have any questions, give me a holler, rraker82@yahoo.com. Don't be a stranger. Post a comment if you'd like. Shoot me an email. I hope this has been informative for you, and I'd like to thank you for viewing.